All right, who's ready for a little bit more YouTube Algebra 2 fun? I know you all have been loving it. Good news, this is our last section of notes for the year. So, section 8.5, solving rational equations and inequalities. Let's get started. So, let's just recall what a rational equation is. A rational equation is simply an equation that contains one or more rational expressions. So we could have something like the following: x plus 2 all over x plus 5 equals x minus 7 over x squared plus 4. Okay, we have multiple rational expressions. This is just a constant, and that's okay. Or we could have something like this: x plus 7 over x minus 5 equals x plus 4 over x minus 1. Again, this is a rational equation because we have an equal sign and there's two rational expressions. Who recalls what this specific type of rational equation is? It's a proportion. Okay, and there's a lot more examples that we could go through, but the main thing is we have to have a rational expression in our equation with an equal sign. So here are your steps for solving rational equations that you can always refer to. First, you're going to factor the denominator and find the domain. Now recall in some of the other work we did, finding the domain was optional. In this case, we have to find the domain. Step 2, find the least common denominator. So you just practiced finding your LCD when we were doing adding and subtracting. So you're going to continue with that skill. Next, instead of rewriting every fraction with the LCD, we're going to multiply through by the LCD. By doing so, that will allow us to simplify each fraction and the fractions will completely cancel out. No more fractions. What you'll have is just a regular equation without fractions. There may be a quadratic in it, but we're going to solve that equation. Lastly, check for answers to see if there are extraneous solutions. This is not an optional check. This is that you need to check for an extraneous solution. One of your answers may not fit that domain. Okay, let's look at a couple together here. So our first thing we're going to do is factor and find the domain. The good news here, nothing is factorable, but let's find our domain. What's going to make this denominator be 0? We just set it to 0, right? And same thing, that will be the same thing. So my domain in this case is x such that x cannot be 0. So any solutions that I get are good as long as it's not 0. Now we're going to find our LCD. So the LCD is made up of our factors in our denominator. The x shows up twice, so we only need it once. So our LCD is 3x. Once I find that LCD, we're going to multiply every term by that LCD. So I'm going to take that equation I had and we're going to multiply by the LCD. Now everything is going to get it, so you can multiply it on both sides if you want to, or just remember to distribute it to everything. By doing that, it's going to allow us to simplify each fraction. So if we look here, right, 3x times 2 over x, the x on top will cancel with the bottom. So we'll simply just get 3 times 2, which is 6. Same deal, 3x times 5 over 3. In this case, the 3's will cancel, so I'll be left with 5x. And here, 3x times 7 over x, the x's will be canceled, so I'll be left with 21. Now we have a very nice linear equation just to solve. Isolate the variable, we'll subtract 6, 5x equals 15, and divide through, x will equal 3. So before I go ahead and just circle my answer, we need to check that answer. So the domain said any value works as long as it's not 3. Sorry, as long as it's not 0. So is this 0? Nope. So it is good to go. Here is my answer. Let's look at number 2. Number 2, we want to find that domain first. And again, everything is factored. So my domain, if I set this to 0, I'm going to get a positive 2. So that means x can be anything but positive 2. Now we're going to find our LCD. The LCD is made up of our common denominators here, right? So we have just simply x minus 2. Now we multiply our rational equation by our LCD and distribute it to everything, and it should allow us to cancel our fractions. So if we distribute this all the way here, x minus 2 will cancel with x minus 2. We'll just be left with 5x. If I distribute it to the 7, nothing cancels, so I'm left with 7 times x minus 2. And then lastly, distribute to our fraction of 10 over x minus 2, and that'll just leave me with 10. Now, nice equation again, without fractions. Just distribute, combine like terms, clean things up a bit. Subtract our 7x, we get negative 2x equals negative 4, and x equals 2. But remember, don't just circle, we need to check. So can x be 2? Well, if I go back to my domain, it says it can't be 2. So this is no good. So this is our extraneous solution. So that means there's no other ones that work, so there is no solution for this problem. Or recall the no solution symbol. Okay, so I'll pause there in case you need to look at that again. Okay, let's look at a couple more examples of rational equations. And I did a few of them already out that we can go through. So for number 3, again, we're going to find our domain. So we do have to factor our second denominator here. That's going to give me 1 and negative 1. This also gives me negative 1. So our domain is everything but plus or minus 1. Our LCD consists of using our factors in our denominator. X plus 1 shows up once in each one of these, so we only need it once. And then we have x minus 1. We're going to multiply the entire equation through by the LCD, and it'll cancel the x plus 1's, but we're left with 3x times x minus 1. On our second fraction, it will cancel out everything except for the numerator, which is 12. And then on the last one, there's nothing to cancel out, so we have 2 times that whole quantity. Again, I distribute. Since it's a quadratic, I brought everything over to equal 0. I then factored, and I get 5 and negative 2. I double check that. I just can't be 1 and negative 1, so those are both okay. Okay, let's look at number 4. Number 4, we're going to find our domain. In this case here, everything's factored, so it's just the x such that x cannot equal negative 3. This 4 is completely fine. There's not a variable in my denominator. Now you can do 2 options here. You can find your LCD, or you can pause and say, aha, this is just a proportion. And how can I solve proportions? I can simply cross multiply. So x squared plus 3x equals 28. Quadratic, so we set it equal to 0. Factor, x plus 7 and x minus 4. So I get negative 7 and positive 4. Are those okay? Check our domain. That is okay. Remember, for these answers with multiple solutions, you can always write it in a set too. This is not an ordered pair, it's in set notation. Either one of those is fine. Okay, so again, this was a proportion because we just had a single ratio equaling another single ratio. So we can cross multiply. Whereas before, right, we had 2 different terms over here. So we can't just cross multiply. All right, let's look at the last example of our solving rational equations, and that's number 5. So for number 5, first thing we need to do is factor our denominator so we can find our domain, and that'll give us x such that x cannot be positive 2 or negative 5. our LCD, they each all have a negative x minus 2. So we only need that once. And then we have an x plus 5. Multiply through by the LCD. So we're going to multiply everything through by that LCD. Cancels out some things. We're left with 2 times x plus 5 equals x times x plus 5. And then simply just plus 6. Distribute, combine like terms, set to 0, factor, and we get x equals negative 4 and 1. I double check that that works, and we are good to go. So they are my answers. And there you go if you want to take a look at that a little bit more closely.